Hello everyone. Today I wanted to touch on a very important topic. I would say it's premium window installation. I didn't come to this topic right away. I'll be honest, I've got many years of experience, mistakes, blunders, trying out different technical solutions, various materials for installation, and so on. I've come to my own understanding, subjective as it may be, of how installation should be done, which materials are better to use, and which ones are better to avoid. Now, I'm going to share my experience with you. This is going to be a really useful video for everyone, especially for clients who are choosing windows. You need to understand how installation is done better, and with what materials. Maybe my colleagues who work with Windows already know some of this, and some might learn something new from this video. I can say that I used to honestly treat editing as a stage that was not very important. I thought that it was important to design, manufacture the windows, deliver them to the site, and then they would install them as they were installed. In fact, I've come to believe that installation is the most important stage in the entire process. All stages are certainly important, but installation is really the key one. You need to approach it very responsibly and choose the right materials. All stages are of course important, but editing is actually the key one. And you need to treat it very responsibly, choosing the right materials. To apply technical solutions correctly, the hands of the people who are installing it must be in the right place in order to make this installation high quality. Because even the most expensive class window, some premium Schuco, can be installed in such a way that it will be worse than a well-installed Kraus, some kind of Mastech or Alutech. It doesn't matter. So let's figure this out. Today we will talk about installation in the opening, and about installation on the extension, and about window systems, facade systems, unfastening systems in general, about everything. Make sure to watch until the end. Make sure to like, comment, and share your opinions. It's really important for me to get your feedback. I personally read all the comments and respond to everyone. Help me get this video out there because it's really important for me to get your feedback. I personally read all the comments and respond to everyone, so please support this. Let's start with something really simple. This is the installation of a window, of a regular window and door. Basically, these installations are somewhat similar. They are considered a window-door series, meaning they are equal products. First of all clients and everyone watching need to understand that window and door systems are installed with specific spacing for the fastening points around the perimeter. The spacing, I believe, is no more than 600 mm and 150 mm. The fasteners should be placed 150 mm from each corner and from each post in both directions. Well, there are installation schemes for the fastening points. They exist. By the way, I have this really cool installation quality checklist that I created for installers to use when they're doing the installation. Don't ask me to share it, I won't, because it's very confidential information, and I don't want to share it with competitors. This is really important information for me. These are selective names for the installer, focusing on what to pay attention to, where and how to secure things properly, what mistakes can happen, how to connect things correctly, where to seal, like with the gasket, and so on. It's a summary of my experience, some recommendations from suppliers, and so on. There are also the shimming diagrams, the fastening installation schemes, and everything else. So everything you need is there. There are also the shimming diagrams, fastening installation schemes, and so on. So everything is there. In general, the window frame and the door frame are installed around the perimeter, and the facade's linear system is installed only with the vertical posts going up and down. That's it. The horizontal ones connect between the posts. They are not installed to the opening. So there are different methods of fastening here. The sliding system, just like the window and door systems, is also installed around the perimeter with a ball. Well, let's take a regular window. Basically, let's consider the window, the door, and the sliding system at the same time, because they all involve fastening in the opening or around the perimeter with a specific spacing. There are two options for fastening. This is for the mounting plates and through the frame with sleeves. I've tried it both ways. Some installers prefer using mounting plates, but not everyone knows how to install them well enough to prevent the frame from being pushed out by foam. Plates aren't rigid, and foam can make the frame crooked, like an hourglass or barrel shape. If it gets pushed out the other way, it might be due to over-tightening by installers. The point is, mounting on plates doesn't provide the rigidity needed. If it's in the opening, it might be okay, but on a cantilever, the frame isn't rigid, which is problematic. But the point is that mounting on a plate does not provide rigidity to our product. If it's in the opening, it's somewhat manageable, but when it's mounted on a cantilever, frame is not rigid at all, which is very bad, in my opinion. Next, we also used a perforated mounting plate, 2 mm thick, which comes in rolls of 10 meters and is 40 mm wide. You can buy it, cut it to the desired length, and then attach it with 2 screws to the frame, nailing it to the opening. Yes, it's quite rigid, but not all installers know how to work with it because it's hard to bend. If you attach the mounting plate to the frame, insert the window into the opening. Bend it a bit, and nail it down, then this thick 2 mm mounting plate, once attached to the frame and inserted into the window, can't be bent with your fingers like that. it starts to bend and it just tears out of the aluminum, out of the frame, and doesn't hold. You need to insert it into the window, measure all the distances, then figure out where you're going to place the plates, bend them in advance. There's a special tool for bending and so on. Then you screw them in and then insert them into the opening along with these plates. In general, it's quite a complicated task that not everyone can handle. That's why I prefer mounting sleeves. In the past, they used to put a regular Chinese nail, yellow one, on the sleeve. But accordingly, he left it. Why? Because it's universal. Let's say it doesn't hold well. In foam blocks, in gas blocks, in ceramic blocks, it spins and can be pulled out by hand. But it doesn't hold well. The fastener isn't very good. Plus, it looks ugly visually when you screw it through the frame in visible spots. We need to come up with some kind of caps. That head is just not pretty. That's why we moved away from those nails and switched to Blaugel turbo screws. The company Mesenberg sells them, but you can basically get them somewhere else. These are German turbo screws that have a slightly different thread pitch. It's specifically this thread winding, and it holds better in materials that have a softer structure like gas blocks, foam blocks, and so on. Even in ceramic blocks, this turbo screw holds because ceramic blocks are actually a material that not every fastener can handle, and regular dowels don't work. So, ceramic blocks are needed. If we're mounting on plates, we use large nylon dowels, 10 by 100. Or you need to use chemical anchors, or these turbo screws actually hold well in that ceramic block. That's why we decided to keep such a versatile fastener and use it everywhere. What's the advantage? The advantage is that when you screw the turbo screw through the frame and insert a wedge around the turbo screw, you can align the frame precisely using a laser, press it down, and it compresses the turbo screw against the opening through the wedge, fixing it in place. You see, it doesn't bend. And then, when we foam it, the foam can't push it out anywhere, neither to one side nor the other. So, the frame becomes rigidly secured, perfectly leveled in all aspects. I recommend these turbo screws. We're using them everywhere now. And actually, we don't even put any caps on because they have a pretty nice head. They're not yellow, they're more silver, and they actually look quite decent, like good quality German fasteners. It's probably 2 or 3 times more expensive than a regular nail, but it's worth it, and we recommend using them. Plus, the coating is even a bit better there. Yes, it's not stainless steel, but still, this coating is better. And when it goes through the aluminum profile, the likelihood of any corrosion occurring is practically zero. That's why these turbo screws are a pretty safe and great fastener for installation. We use these turbo screws for the sliding mechanism. We prefer to install the sliding mechanism under the gutter, meaning there are these plastic gutters at the bottom, on the side, and at the top. We take out these gutters, remove the sashes, and install the frame level. And there, right under the gutter, we use 2 of those turbo screws, one in the outer chamber and one in the inner one. We screw them in with a certain spacing. The bottom spacing should be more frequent, around 300 millimoles. The bottom frame is crucial in the sliding mechanism. The large sash and weight shifts require frequent fastening. Turbo screws can attach the sliding mechanism. Well, it's clear that the sash is large, and the weight shifts, the fastening spacing should be more frequent. Well, in general, you can also attach the sliding mechanism with the same turbo screws, which we successfully do. We talked about installation in the opening. If we have installation on the extension, there are actually several options for truly high-quality installation. The first option is using an extended warm profile, the so-called triatherm warm profile for extension installation, or they also make warm supply profiles from it. So there's triatherm and there's compact foam, which is an equivalent. They are all represented in Russia. You can easily buy or order them. But in fact, to be honest, I only had one object made using such material. It's ordered very rarely because it's quite expensive. Triatherm forms a casing around the window extension using turbo screws to attach to the concrete. This material is very dense. With the same turbo screws that are used to attach the window, it gets screwed into the concrete outside, depending on how much extension you have. They come in different widths or rather depths, right? If the extension is 100 millimeter, then it will be 100. If it's 150, then it will be 50, 200. It's calculated. A casing is made around the window. They make such eggs at the bottom in places where the maximum load is. This is how they are screwed in to add extra load-bearing capacity. When we make this casing out of triatherm, we don't need any additional elements like brackets or other things that bear the load. This element serves as both a load-bearing component and an insulator. A casing has been formed from this material. Next, the window is inserted directly into this triotherm. And it is also screwed with the same turbo screws directly into this reactor, foamed. Then there is sealant or tape. Everything is mounted like a window. Well, this is a really expensive premium type of installation that we actually use very rarely because there are alternatives that allow you to do it cheaper, but they are also not worse. And this includes the use of external fasteners like Nelson, so-called. It's also a German fastener that has been developed, and we buy it successfully. And this is, for example, the use of external fasteners called Nelson, also German-designed fasteners. We buy them successfully. Recently, to be honest, we switched to it because before we tried to save a bit. It's not particularly cheap, actually quite expensive, but it's very convenient because it comes with lower brackets and braces that bear the load. There are also special support plates, like a U-shaped plate, a rigid one that you nail to the opening and then screw the window into it. And it's not just a mounting plate, it's rigid, right? So it firmly fixes the frame for you. And at the bottom, there are special load-bearing brackets. So this is a fastener specifically designed for external window installation. Very professional, cool, well thought out. We extend the window on this fastener, then secure it, and it stands firmly. And around the window, we make a casing. It's out of regular foam board. Just like Tretherm, we simply nail it down with facade mushrooms around the opening along the perimeter. And we make a casing out of this foam board, also foam it, seal it with tape, and stick it down. In this case, the foam board doesn't serve as a load-bearing element. It only acts as an insulating material, as a thermal barrier, to create a warm contour around the window. In this case, the foam board doesn't serve as a load-bearing element. It only acts as an insulating material, as a thermal barrier, to create a warm contour around the window, and the actual load-bearing capacity and height are supported by this external Knelson fastener. And just like that, the same turbo screws are used to attach the window to the Knelson plate with turbo screws as well. Everything is quite convenient, clear, and works well. If regular windows are on the parapet, I often used to just use the Alutech system support profile. I can't say I don't remember anything bad happening to it, like there were some big freezes on it, there weren't any complaints. But at the same time, technology does not stand still. Conscious people look at the internet, they talk a lot about the warm stand profile. That's why we've decided to use only warm support profiles for all our products in our projects, which are at a fairly premium level. So for those windows that are simply installed on a raised surface, like a parapet, we just use a small support profile, 30 millimeters, that's warm. We also use Tretherm or Compactfon in Meisenberg. It's up to you. There are two competing materials that are actually about the same price, and that's what we go for. It's a pity that Alutech actually doesn't have a warm support profile for windows and doors because they only have a warm support profile for the development of the system that you can buy from Alutech. So you have to purchase that separately. We usually purchase this in Meisenberg as well. Along with the turbo screws, we take this warm support profile, but they really only have standard sizes there. If you need to mill something non-standard, it's more convenient to contact Compact Foam Materials, which is the supplier DM Chemistry. We use their materials a lot. Sometimes on the project, we combine Compact Foam and Meisenberg. Whatever is more convenient for us, we're selecting technical solutions. That's if it's in the opening. If we have a floor-to-ceiling window and we need to raise it by about 150 to 250, 300 millimeters at different sites, sometimes the window is raised above the concrete floor. Sometimes it can be raised 300 millimeters above the concrete floor. Making some kind of sing-alongs under the window is of course the same idea, because often they interfere on the contrary, or are made at that height, or somehow else. Theoretically, of course, you can ask the client to create a base for our window at a height minus the support profile and the installation seam. We sometimes do that too, but often clients don't create any bases, so we also use a tall, warm support profile at the bottom. So we use this ordinary stuff. We usually use compact foam for these purposes because it's easier to mill to the required height and cross-section. The designer sketches out what support profiles we need for the project, gives me the request, and I order them and bring them to the site. It's convenient because the base, where we have the facade system, isn't needed at all. It just gets in the way. It's better to extend the post from the concrete to the finished floor by 200 millimeter, so there's room to install the bolts and properly secure the base to the concrete, ensuring that the load goes entirely onto the concrete. Because facade systems are usually heavy and large, it's not a good idea to place them on some kind of glass block. It's better to install them on concrete. It's not very good to place them directly on the base. It's better to place them on concrete. So, where there are facade systems, we always tell the clients that a base isn't needed and they don't make one. Or if it's already been made, we ask them to dismantle it because it just gets in our way. We extend the post down to the floor and create a sandwich there, insulating everything from below with foam board, and we make it a warm joint. And can you imagine, for example, if the facade structure is large and there's a door integrated into it? So you have the post extended, the facade is in place, and there's that distance by the door. You're not going to ask the client to measure things out so that they can lay bricks by the door, right? That's not very professional. That's why it's most convenient to use a warm support profile that is directly screwed to the threshold through the sealant. From below, you insert it from the support profile to the line. There we also make corners with a stiffening rib, which fix it from this kind of deformation in depth. That is, we fix it really well, foam it, seal it, and accordingly. But this is actually a very cool material. The same goes for sliding doors. We also use a warm base profile for sliding doors. But there are some points here. If the height is small, we use a small warm supply profile. If the height is larger, use a big warm supply profile. If the height is large, 250 millimeters, then you can simply make a healthy warm support profile. But firstly, it will be expensive, and secondly, it will probably not be very convenient for editing somewhere. Installers say concrete is uneven, so supply profile is 2 centimeters shorter. On site, wedges level it before securing. Concern: warm supply profile designed for loads might have wedges sink, affecting leveling. When installers set up the product, they leave wedges between the supply profile and concrete to level it. There's a belief that the warm supply profile handles distributed loads, and wedges might sink slightly, affecting leveling. I haven't experienced that. But there's this opinion that this warm supply profile is designed for such distributed loads, and those wedges might sink in by a millimeter or two and somehow affect the leveling. Honestly, I haven't experienced that, even though I've moved a ton of projects exactly this way. But we came up with a different solution to kind of get away from that, to avoid it. Before, I used to try out and experiment with some fiberglass tubes on studs, and I did it this way and that way with this warm supply profile. Actually, we recently tested this on a project, and now we're using it on all our sites. There are adjustable supports called Hilst. They are used for adjustable installation of tiles, for example, outside. So, we place the sliding door on these large black adjustable plastic supports. Moreover, we create a platform. Top, but it's quite small. We make the bottom platform, then we kind of flip it over and place it on top like this. Sometimes it even sticks out at the edges, and the installers usually trim it all off. And it has this threaded adjustment, a big black support. We place them at intervals. The supply profile on top is small, 30 millimeter. Under it, we get a frame, a support profile, and under it this support, the hill. What is the purpose of the supply profile? Technically, we could place this support directly under the frame. We install the supply profile so that we can later create galvanized connections at the bottom, so that we can bring the waterproofing in. Even if we don't create a galvanized connection, when the client brings in the waterproofing from the outside, they still need to attach it somewhere. So there should be some kind of subframe or material to which all of this will be screwed, glued, or soldered. These hill supports have proven to be really great because they allow for such minimal and cool adjustments, and everything is perfectly leveled out. They can hold a really great load. Nothing will sag or get crushed. Between these supports, we use foam board and foam, so everything gets foamed, and we do the galvanization at the bottoms on both sides. That is, on the different parts we do galvanizing from the inside and outside as well. So overall, I've come to the conclusion that for all products, we should do galvanization at the bottom everywhere. Galvanized bottoms of facades, slides, windows, even warm profiles, secured with dowels, Cartlinger 791. On the windows, we have galvanization at the bottom. Even where the supply profile is warm, we still do galvanization on the outside at the bottom, which we secure with dowels through the sealant into the concrete, and we also specially apply this sealant there. We use the Cartlinger 791 sealant. I take the sealant, a structural sealant. Why do I choose this one? Because the STIS, regular, STIS-A, and STIS-B, the external STIS-A, it doesn't hold the lower joint where there's a large amount of water. Everything will leak through. That's why we need to ensure good waterproofing at the bottom. Everything will leak through. That's why we need to ensure good waterproofing at the bottom. And that's why we use this black Cartlinger sealant on all the bottoms, all the window sills, and the bottoms of all the products. On the outside, the sealant hardens and becomes like rubber. It turns out to be a really cool and quite effective solution. Yes, you can use it in distortion. There's also this liquid waterproofing, Francosil, from SDM Chemicals. You apply it, then stick a canvas on it, and then apply it again. It hardens afterward. Yeah, that's also an option. It's actually a great solution, but it's really expensive, so use it rarely. It's just more convenient and not as bad to just do galvanization and nail it down with sealant. What other advantages does galvanization have? Because clients prefer to solder the waterproofing on the outside rather than mechanically screw it on. That's why we do galvanization everywhere. And then the waterproofing for terraces, it all goes on top, we solder it. That and everything works well. So these are the recommendations I have. Galvanization. On the outside. So basically we made the lower base on these hill supports for the sliding part. In the same way, when we have a sliding system on the extension, we use these system brackets. Well, that's probably more applicable for a 2-rail frame. If we have a 3-rail frame, it's very deep, 230 millimeter. If it's extended, then of course you won't get by without Nelsons. There, we use brackets, just steel brackets, on the outside, with a diagonal brace. placing them all around the perimeter to secure the sliding part so that it's rigid. At the bottom, accordingly, there are also these brackets on which this bracket support installation profile and the sliding frame are placed. In general, everything is basically doable with the cantilever fastening for both the sliding parts as well as the windows and doors. Next, let's talk about the facade system, the post and beam system. Similarly, if we're installing it in the opening, there's really nothing complicated about it, just regular mounting plates. We take standard Alutech aluminum, attach it, and secure it with anchors, fastening the post at the top and bottom. Like this, we secured it at the bottom. If we have the option to extend the post, we secure it with bolts. If we don't have the option to extend the post, then we secure it above the beam using stainless steel bushings with decorative washers and screws. This is how we tighten it. This is if it's a heavy glass unit. If it's small, of course, you can screw in 4 or 6 self-tapping screws from the side of the seals, like from the tip of the post, and that's also principal and acceptable system solution. And then we make a sandwich, the perimeter connection of the sandwich. Why did we choose a sandwich? Because it's convenient. You extend it to the length you need, like 250 millimeters, and you extend the sandwich piece down to the concrete. If the distance from the side is this or that, big, small, the sandwich is a universal material. You can cut it on site, adjusting the width of the strips as you need, up to the opening, down to the bottom, from the side, from the top, however much you need to extend. So next we extend the sandwich, fill it with foam, and we try to fill the space between the beam and the floor with some kind of insulation, foam board and so on. It's not always necessary, of course. Basically, the sandwich itself is enough. But now, since clients have started asking what to fill the space between the beam and the floor with, we decided that foam board isn't that expensive, and we can fill it all with foam board and foam all the way to the depth of the post. And many will probably say that it's better to use insulation wool because the post has thermal expansion, it moves, and foam doesn't work. So we decided that foam board isn't that expensive, and we can fill everything with foam board and foam all the way to the depth of the post. And many will probably say that it is better to use cotton wool because the stand has thermal expansion. It moves, foam does not work. But all of that is nonsense. We've been doing it this way for years, and it's better than insulation wool. Wool settles, accumulates moisture, and creates voids. These voids can't be filled with foam. It doesn't stick to wool. I don't like insulation wool as it settles, accumulates moisture, and creates voids. These voids can't be filled with foam. It doesn't stick to wool. In general, I don't like wool. We've used insulation wool so much, it's terrible. You can't apply sealant on wool from the inside. You can only use tapes. These tapes don't stick to the wool. They come off. In short, this is not a very good solution. I don't like it. We always use Penoplex and foam. We've completely moved away from insulation wool. If we have an installation on the facade extension, then we carried out a huge 7.5-ton glass facade. I have a video on YouTube where we carried out a huge glass facade that was 8.2 meters tall on an extension using these massive brackets. Use any weight or product on an extension. Key is bracket design, small or large. Facade on extension means supports under each post of the supporting bracket, which can be smaller or huge, with a bunch of anchors made from some thick steel. So, if the facade is on an extension, then it's only brackets with braces that are placed under each post. Here are the vertical posts, and at the bottom is the supporting bracket. At the top, there's a bracket that doesn't carry any weight load. It only supports the bucket load. So the bracket at the top is simpler, or just some kind of mounting plate. We secured and framed the facade, and around the perimeter, we do exactly the same thing, creating a frame out of foam board. Just like around the windows and the sliding doors, there's also a frame made of foam board around the facade, which kind of insulates it. Then we foam between the facade and the foam board, we bring the sandwich right up to the foam board, and we foam everything. And it creates a kind of warm contour. It's actually very convenient. Yes, there is a solution where, again, cotton is used, and some galvanized boxes are made on the outside. It's very complicated, time-consuming, expensive, and inconvenient. It's all cotton there. You can't control it. The installers poorly fitted it somewhere, and it sagged in some places. Then there were some drafts and freezing. Honestly, at one site, there were constantly these drafts. We went there, foamed it up, sealed it, took apart those joints, and added insulation there. I don't like this solution. Honestly, I don't like it. When people tell me about fire resistance, saying that foam board is flammable and so on, we worked on private projects, and that's really not a problem. No one pays attention to that. But we also worked on some larger projects. We're currently designing and installing a big restaurant, but we also worked on some large projects. We're currently designing and installing a big restaurant. The requirements were quite significant, serious. The right solution there is to create a fire barrier in front of the foam board. So, the facade installers, those who do ventilated facades, they made a fire barrier in front of our foam board. And, in principle, this is also an acceptable solution. This is regarding the installation of the facade on the extension. Next, when we installed all our products in the opening or on the extension, finished it with foam board and sealed it, we then have the question of what needs to be done regarding vapor and waterproofing according to GOST and the rules. On the outside, a vapor-permeable layer is created, which is a layer that blocks water from the outside and allows the vapor that forms inside, which could be some capillary moisture or condensation, to escape through this layer to the outside. Next, inside we have a vapor barrier layer. It's a layer that prevents moisture from inside the room from getting into the installation joint. Basically, opinions are divided here. There are installers and companies that say it's unnecessary, that it's all just a marketing ploy, something made up to sell more materials, that all these GOST standards are false. But I tend to believe that it's not just done for no reason, and it's really important to have good vapor and waterproofing. So there are two options here: sealants and tapes. Sealants are Stiz A, Stiz B, or some analogs like Ecru and so on. So it doesn't matter if it's a sealant for outdoor use, indoor use, a special one, or if it's tapes. The tapes are divided into two types. The first type of tape is the standard tapes, the cheap ones that are used on PVC windows. Even if we take some full butyl tape, in my opinion, it's all just nonsense. Why? Because those tapes on the outside, they just don't stick at all. The installers tell me, these tapes are great, you just need to staple them on to the gas block and nothing will fall off. Guys, seriously, with a stapler, with a gas block, well, I've installed so many of them, and even when they were stapled, they still come off. Water is leaking in here. From the inside, they stick this tape on, and it seems to adhere even if you treat it with a primer. Even if everything is done carefully, it still really comes off. Then the finishers or facade workers come in, and these tapes are hanging down with goo. They just rip them off. They get removed because they get in the way. In short, I really don't like these cheap tapes. If maybe someone can actually do it properly on some small products, I haven't seen that. They foam it up, stick the tape on, and the foam pushes the tape out, it tears off, and damn, it just hangs there like goo. In short, it's all really bad, inconvenient, and I don't like these tapes. If you're going to use tapes, then use German tapes. There's the Finca tape, and there's a tape from Meisenberg. Well, there are different tapes, like the Sordel tape. I don't know if they still bring it in or not. It's basically a sheet, and there's a special adhesive layer across its entire width. It has really good adhesion. This tape can withstand a large amount of exactly this water pressure in pascals or however it is measured. So this is a really great material that provides reliable protection for the installation seam. In my opinion, there are only two options, using sealants or these expensive German tapes. Because those cheap regular tapes, as I said, they come off and don't hold well, so I actually use both, but I prefer to use sealants because I think they work and they're quite versatile. So, for example, when there's a crooked opening, like with a ceramic block, which usually has a very textured opening, you can basically foam it and seal it with a sealant on any opening, no matter how crooked it is. And it's easy to check how the installers applied this sealant. If it's well sealed, it won't go anywhere. We use Stiz A outside and Stiz B inside. Installers seal lower window connections with a linger because Stiz A doesn't work there. German tapes are more expensive, but great. There you go. Or these German tapes, they are definitely more expensive, but they're really great too. Basically, you can also stick the tape on the outside. There's a universal one there. So there are tapes that are universal for both outdoor and indoor use. It's the same tape. You can stick it on the inside and the outside. Right. So basically, it's up to your taste. But we use sealant and it's nothing special. Everything works well, it's standing, nothing is leaking, nothing is selling, nothing is seeping. I hope I didn't overwhelm you too much. Maybe I forgot to mention something. If you have any questions, feel free to write them in the comments and I'll respond to them. You can also submit your requests. I calculate and install projects all over Russia. We already have projects in different regions like Chelyabinsk, Tyumen, Kazan, Sochi, Krasnodar, St. Petersburg, Moscow. There are a lot of projects in different regions. We cover a lot of cities taking on projects for glazing cottages, so write to us, leave your requests, we'll offer good prices, and, what's very important, quality installation that's been tested by experience. Goodbye, everyone.